In such theoretical spectroscopy questions, we don't exactly remember all the, like wavelengths. We actually remember the functional group wavelengths, and others we try to guess it, okay? So what we know here is, so I actually told you how many bonds are there. Well, so I broke down these into basic bonds. Now what I would do is, we have to actually, by the way, I told you like hydrogen bond is strongest, then also nitrogen bond is strongest, because obviously, nitrogen and hydrogen, wait a second, I have to check on the periodic table, let me check out. See, nitrogen has atomic number 7, as you can see, right? The black number in the corner, above the N letter. So it has 7 atoms, 7 electrons actually. So what happens here is, so let's say this is the proton of nitrogen. There is the first shell can store 2 electrons totally, and second one can store actually 8 electrons. But after, but the total electrons we have is 7. So 2 I have already placed. Now there are 4 electrons actually. No, not 4. It is actually 5 electrons, because 2 I have taken, 7 minus 2 is 5, so 5 electrons left. I place them 1, 2, 3, 4, 5. Yeah, 5. So the total vacancy here is 2. Here total vacancy is 8. It can fill up for 8 total electrons. I have 5. Our have is 5. So to fill it, I have to put 8 minus 5, which is 3 electrons. So, and if I, see, this is a full shell already. If I remove this, still it is a full shell. And if I fill the shell, still it's a full shell. And our target is, when you are hungry, you fill your stomach, then you are stable. So like that, he's hungry. So either he has to throw away his stomach, or he has to fill his stomach to be, stable. So what does it have to do? If it takes each electron, it has to eat 3 electrons. If he has to throw away, so it has to throw away, his stomach, then it has to throw away 5 electrons. Okay, to get empty state or something, right? So which is much more costlier? Obviously this one, because it has to fight the proton attraction. Fight proton attraction, because obviously the proton is also going to be the same amount, which is 7 protons are there, and it can actually attract all these 7. That's why these 7 are there. But if I try to take 5 electrons, that's way too much to lose, because the proton would try to attract it, and it needs very heavy energy. So obviously our nitrogen won't do that. It will rather eat 3 electrons. That's much less. Obviously it can't attract that much, but it can try to do that actually, because it needs to fill the electrons. But we have 2 options, and the second option is much more easier, filling electrons. It's much more viable. So what happens here is, it wants charge, so it is negative. So, and our hydrogen is positive actually, because I told you hydrogen has 1 electron, and it wants another electron. So what happens here is, our the nitrogen wants 3 electrons, and my hydrogen has 2 options. Even if it loses, it can lose this 1 electron for an empty shell, same stuff, okay? And if it gains electron, it would fill the shell. But still both are equal to 1, because it has 1 electron, needs, by the way, this total is 2, 2 is total need, and it has 1 electron, so it needs 1 more to fill the shell, and it can even lose this one and get the empty shell. But getting empty shell, that's kind of crazy, but yeah, it can get an empty shell. So it just, both the options are equally viable. Like it can even throw, in both the cases, same case, both the cases, only 1 electron is getting interaction. Like either you have to throw this 1 electron or take this 1 electron, it's the same stuff. So that's why there's no problem with hydrogen. But yeah, this guy needs 3 electrons, eats 3 electrons. So it takes electrons from here, 1, so it's 1 electron satisfied. So to satisfy all of its electrons, I need another hydrogen actually. Another hydrogen, that's what I did here. 2 hydrogen and another carbon. But the thing is, this is an ionic bond. This is not sharing. Not sharing. This is give and take, okay? Someone is give and take.